I forgot to put in for my substitute last week, and I just did it this morning. So I am not supposed to be here tomorrow. I'm supposed to have a sub so that all the chemistry teachers can get together and try to work on stuff through at least through Christmas, if not through that next 6 weeks too. Okay, I do see Decker online. I see Sarah. Let's see. I think I already got Chase. Nope, not Chase now. Got Natalie. Oh my goodness. I will double check remote one more time before I stop everything. All right, so for this opener, yes, we've mentioned igneous, but we specifically mentioned igneous minerals on Friday. We didn't really go into rocks. So not like diamonds and emeralds and those things, because those are the ones we did talk about. Can you tell me a name of an igneous rock? A specific type of igneous rock without cheating and doodling. Yes. Yes. Obsidian is different because that is what we call extrusive. That was one that we took a look at. We actually looked at another one last week too. That was igneous.
One?
Yeah. Although I picked up the wrong one. The one that I picked up was called scoria. That's this red one. Pumice is actually the one that's next to it. It's even lighter. Well, I haven't checked to see if this one will float in water or not, but they both come from explosive lava activity. So they have lots of air pockets in them. It's just one is mafic and the other is felsic. And we'll get into some of these. Now, there's going to be a lot of weird words you have never heard of before. Please do not try to do the assignment yet. You will have no idea what these words mean. So the two that we talked about were pumice and obsidian. Those are the two that you looked at. And I'm sorry, those of you that are remote, I can't like send them through the screen to you. So did anybody want the paper version of this? Yes. You want the paper version or? Okay. I normally print off about 25 of them, so but it's the same thing that's in Canvas. I don't think I've altered it. But igneous rock. Now we're going to talk specifically about the texture today, the composition tomorrow, and then we're going to go back and talk about how magma or lava, for that matter, affects the production of said igneous rock. And then we're going to review. It's going to be the rock cycle. It's going to be minerals and igneous rocks. That's it. On Thursday, I've made the test. I've made the review. I have not made the Kahoot. I'm hoping I have enough time to go through and make the Kahoot to be able to do the review. I didn't have enough time to get through it yesterday.
You weren't joking about this.
No, you're not going to know what the heck these words mean. So just wait. But igneous means that it comes from molten earth. If it's molten earth in the ground, we call it magma. And if it's molten earth that comes out onto the surface, we call it lava. Now, those two words we've talked about, and you should have really known those anyways. But it is what they call parent material. You have to have molten rock, and then eventually it cools, and it solidifies, and it crystallizes, and then that forms some type of igneous rock. There's different types of melting of magma, and we should be doing that on Wednesday. Yes, the pheneritic and extrusive and intrusive, there's a lot of different words that I'm almost positive most of you have not heard of before. In fact, I had to go back when I was doing this, as I was making the assignments and making the tests. I was like, okay, which one is this one again? Is this fine grained or coarse grained? I found the actual key for the igneous rocks. This is one of the two that I actually found. And if you want to take a look at them as we're going through the types of rock, the one that I like, I think now my new favorite type of rocks are pegmatites. That they have these huge crystals in them. Some samples are a lot better than others. So, like I said, if it's inside the earth, it's magma. As soon as it comes to the surface, it is now lava. Magma pulls a lot slower. Lava pulls a lot faster, and it's going to change the grain, the texture of the particular igneous rock that you're looking at. And so we're talk about magma. We're going to come back and go in depth with magma on Wednesday. But if the rock comes from lava, it has exited the earth. That's what the prefix X, outside of. That is considered extrusive. It still came from molten stuff, but it went out of the earth, it exited the earth. Extrusive igneous rocks are things like obsidian, pumice, scoria, talc, breccia. There's a couple of different types. And I've put some images into the notes. And if you guys do get note-taking assistance, because I know I have some that do it, you've got to re-download to get this new stuff. They're not just going to pop up on your chain. You actually have to open up a whole new thing. If it comes from magma inside the earth, then that is called intrusive. They cool a lot slower if they're intrusive. The grain is a lot bigger if they're intrusive. Extrusive, the grain is normally a lot smaller. Sometimes they have air pockets in them, which is the case of the scoria and the pumice. So, extrusive from lava, volcanic rocks. Intrusive inside plutonic rocks. The reason I looked it up because I was like, why are they calling it plutonic? Like, look up, you can see this, the god of the underworld, of Hades. So inside the earth, that's where that came from. Still more on magma. Cold weather. Masks. Ugh. Three major components. The molten part is called melt. Oh my gosh. So the liquid part is melt. If there are solids, and there's not going to be a lot of different types of solids inside magma, but if there are, they're going to be a silicate, which is made up of silicon and oxygen. They're the two most common elements that are in the crust. The reason why they come to the crust is because they're lighter. We'll talk about Bowen's reactor series on Wednesday. That things that are deeper in the earth tend to have more of a calcium composition. Things that are closer to the crust tend to have more of a sodium composition. You do need to know how to read that map. But we'll get to that in a couple of days. Volatiles. Water vapor is going to cause some of the largest voids with geodes, and I ordered a whole bunch of geodes. They'll be here Wednesday. With geodes, it's the water that's inside it that gets trapped. It heats, produces steam, tries to expand, and it literally blows up the geode like a balloon before it completely solidifies. Most of the ones that I ordered are probably Moroccan. They're all going to have the same type of crystal structure, very pretty, shiny, small crystals all over the place. Every now and then with the ones that I order, I get one that's solid. I looked at buying a geode cracker. Those things are $500. So I didn't order one of those. It's basically a soil pipe cutter. Got like a ratcheting chain around it. Put the geode in it, put the chain around it, pick everything up, and from this little knob, it squeezes it and then pops it in half. I couldn't justify buying a $500 tool that I'd only use to open rocks. Maybe I can find a used one on eBay or
You
something.
said 500.
Yeah, the type of cracker that's needed for specifically for geodes, it's for like a 12-inch soil pipe.
I don't know how I opened my first geode.
Hammers.
Hammer and saw.
That's what I've actually ordered a couple of the specific picks that are used for opening rocks. But I'll bring those up here this week and probably after the test or maybe after the review on Thursday. I didn't buy one for everybody. I ordered 50 of them. So if you really don't care about rocks, you're not going to get to open them. Although I do have a class that only has like 5 students that are not remote later on in the day. So they're just getting smaller and smaller. But water vapor is going to cause your largest voids. We call them vesicles, like air pockets. But there are other gases that, when the thing violently comes out of the volcano, it causes these rocks causes causes things to expand, to form these little bubbles, which makes them lighter.
Cloud, working like
Well, most of it is going to be melt, most of it's going to be lava, but yeah, there will be some solid parts that will come out with it. Depends on how violent the explosion is, honestly. And the entire sides of volcanoes can be blown off if there's enough pressure behind it.
really.
Yeah, that's what happened with, was it St. Helens? I'm gonna say it was St. Helens, like the whole side of the volcano, the whole side of the mountain just blew. That happened in the 80s. I was a little kid when it happened. It caused a lot of really bad weather that next winter. I want to say it was St. Helens. Okay, hold on, I keep hearing noises. Yes, I keep hearing noises. Let me make sure that it's email and it's not people trying to ask me a question. Here. Oh, what happened? No, I want you to freeze. I pushed something weird. There we go. Let me check and see if that was a question. So, the cooling down of magma, especially magma, not lava, is a very slow process, and certain minerals, certain types of rock, certain chemicals will solidify at different rates of others. Where am I hearing these noises come from? Is it? Oh, here we go. Cami is down with issues. That's horrible. Okay, I don't know why I keep getting messages for that child. That's not good. Cami's not working. That's on my chemistry quiz. ClassLink is down and having problems. I think that's why some people get into their Canvas and stuff. I think. I don't know. I know my side of Canvas. Okay, let me get back to my right slide. All right, so anyways, you have certain elements, certain compounds have different melting points. And as they cross that threshold with temperature getting cooler, they start to come out of, for lack of a better way, we could call it the magma solution. It's molten rock, it's not water. And they do so at a very, very specific rate. So certain rocks, things like olivine, which I thought I had olivine in here, but I don't. They're the first type to precipitate out. And then your silicates are the last ones to precipitate out, which is in the crust. Because they're the less dense, they're the last ones to do it. Your more dense things are going to precipitate out first. And all the texture is, and that's what we're about to focus on today, is the size, the shape, and the arrangement of what the grains of the rock looks like. This is crazy. Which I do have samples. I do know my igneous ones. I like the pegmatite. It has to be a specific type of pegmatite, but I don't know what this giant crystal is inside this. It doesn't tell me. All right, now we're going to start getting into some weird words that you've never heard of before. Actually, that's on the next slide. There are certain things that affect how large a crystal is, and this carries off to the next slide. I couldn't fit everything on one slide. It's just, the tape would have been super, super, super tiny. But how quickly it cools. If it cools slowly, you're going to have more of a coarse grain, larger particles that you can see with the eye. If it cools a lot faster, then you're going to have a finer grain. If it's extremely fast, then it can turn into a glass like obsidian or pitchstone. So, and I know it doesn't look like it. The obsidian is obviously the glassy one, and it does. It looks like glass. But so is pumice. It just has all these air holes in it. It's still highly glass content. This is a lot lighter than that other one. But when you think of glass, you think of the obsidian, and then you think of its cousin pitchstone, which has a lot of glass content, more of a solid glass content, not quite as many of a frothy, bubbly mix. But this is the most important thing to determine the size of the grain. Very, very slow, mixed larger grain, things like granite. Marble is different. They have the very similar to each other towards the crust, but one of them has larger grains than the other. And then, like I said, the extremely fast cooling rate, this is going to be your glasses, which I took my kids' rocks home. And I forgot to bring them back, but I had a couple of obsidian arrowheads in there as well. One of them, the point broke off, but it came that way. More on creating texture. This is just a continuation from the previous slide. How much silicate's present? That's the chemical formula for silicates. A lot of your minerals, like what you think of as gemstones, have this in some way, shape, or form. And I did bring my book back. And then dissolved gases, specifically water vapor. We did not put the chemical composition on that. Let's move more to it. Not everything has silicate in it. The closer towards the surface, further up in the crust towards quartz, that's going to have more of your silicate. Deeper, deeper, deeper down, there's going to be less of that. More things like calcium, iron. Don't worry, you're not going to have to, I'm not turning it into a inorganic chemistry class. I'm not going to make you memorize chemical structure. We're about to go through a bunch of words that you've never heard of before. So, this, aphanitic. Aphanitic is going to have a quicker cool time, which is going to be a finer grain or a smaller, like when you see flecks, they're going to be a lot smaller in aphanitic. They can have gas bubbles. There's one more. Another one? No, let me go back. If it's extremely fast, okay, so fast would be obsidian, would be pitchstone. Scoria is the red one. This is darker. This is going to have more of an iron content. Pumice is a lot lighter. It's going to have what we call felsic. Lighter is felsic, and darker is mafic. We'll get to those words. I don't think those words are on today's slides. I think they're on tomorrow. If you have pumice at home, it's going to be in those things that when you take a shower, you can just scrub the dead skin off the bottom of your feet. Or if you go and get your feet done. I don't know if you're allowed to do that anymore with COVID. You get your nails done. That's that scratchy rock that they use. And some mechanics, it's in their soap, that lava soap. It's really good at getting that nasty stuff off your hands. So this is an example of an aphanitic. For the ones that I had samples in here, it's the 4 that I mentioned. They don't have to have gas bubbles in them. They can be more of a dense solid like the obsidian and the pitchstone. Tough is, I don't have a sample of that. That's even smaller. That comes from what's called a pyroclastic explosion. You have all the smoke that billows down the side of and there's lava in there too, it billows down the side of the volcano, and it the gases knock you out. Okay, and then with Pompeii and Vesuvius, then the tuff came down and it coated them, and it essentially nullified them. If the people were unlucky enough to still be alive and to breathe it in, it essentially turns into cement in your lungs. Not a pleasant way to go. Hopefully they were already knocked out dead already from the gases. Okay, pheneritic. This is a coarse grain texture. This comes from a slower cooling, which means deeper in the earth. So things like granite. This is an example of granite. Those are going to have a much coarser. The one more after gabbro. Yes. And I have a few of those up here. I don't know which number I want to say. Gabbro is 5. Gabbro 5. Yes. Where you can see the structure, and if I pass it around, you can see the different, almost looks like flakes of color that are in it. And the larger those are, the slower it cooled. It's easier to see it in this guy. You can see all the different types of grain. And I'm so sorry online that at least I put the picture up here. And I was going through using the software that I have for the test questions. They mentioned Gabbro a lot, a whole lot. We're gonna come a little bit more in depth with these guys tomorrow. Like I said, I'm not gonna make you memorize all the chemical compositions.
Sure, it's all in
You're not, you need to know, and what I probably need to do is to go back and like underline some of these words. Porphyritic is a metamorphic type thing where you're going to have both fine and coarse grain. You have a mixture of the two. And you will have large crystals, and they're going to be suspended in a slurry of smaller crystals. The larger crystals come from magma that's cooling down, and then the finer crystals come from much closer to the surface. It could be inside a volcano. It could actually be erupted outside of the volcano. The examples of that: basalt, rhyolite. Oh, in fact, if you ever visit Hawaii, there's a black sand beach. I found out the hard way that you're not supposed to collect it. It's actually illegal. I didn't like get arrested or anything. They were just like, no, put that back. But that black sand is actually crushed up basalt that comes. It's when the lava cools. It's that black rock that then the waves come through and it crushes it up and erodes it and it turns into these black, very, very fine sand. So just, you know, if you go visit Hawaii, specifically Kauai, one of the smaller islands, you're not supposed to collect the black sand. You're also not allowed to touch the sea turtles because they're endangered. I think you can get arrested for that. I would.
now.
Well, I mean, I went scuba diving with my father, and like as soon as we got in the ocean, they were all over the place. And I had an underwater camera, and so I gave it to the, I guess, instructor, guy to make sure we don't die. And so he's like, basically told us to go swim, well, not like verbally, but motioned for us to go back behind it and took pictures of us with the sea turtle. But yeah, I mean, if they touch you, that's one thing, but if you intentionally touch them, it's not good. Huh?
Can't kill them,
Well, they're endangered, so you're not allowed to touch them.
That's stupid.
It's just their rule.
That's really stupid.
So, I don't know.
I've got one.
I also had coconut when I was there, like off the tree, and it was disgusting. It was absolutely disgusting. They were like, coconut milk is so good. And I took a sip of it, like, ugh. 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 Fresh coconut, straight out of the coconut.
Oh, I don't.
Not the dried coconut that you think of. It's really not tasty. I thought it was going to be delicious.
So there's two types of coconut though.
I don't know. The type of Hawaii. They come off the trees.
She's talking about dried coconut, Indian coconut.
Like this is like they literally crack it open in front of you, and then it's almost like you scoop it out with a spoon. Like after you get all the
Ew.
Yeah, that's good. It might be bitter, but it's good.
I did not like it. Glassy texture. This is a specific type. Excuse me, of aphanitic. The two major ones that you're going to see, the one that we took a look at yesterday, or not yesterday, last week was obsidian. But pitchstone is very, very, very similar to obsidian. Has that nice dark glassy appearance. Dark rocks. I said it's not on. You know, I say that, and I don't think I put it on here. No, I didn't. It's tomorrow. Dark rocks. We call those mafic, they're more dense, and light rocks we call felsic, and these are less dense. It has to do with how much iron content is present. The more iron content, the more dense the rock. You have a couple more, and I should be able to definitely go over what you guys are missing. Okay, pyroclastic. This comes from exploding volcanoes. And the lava has actually been ejected out of the volcano into the air, and it's aerated. And those air pockets, then they expand because of the heat, and it forms what we call vesicles, or it's porous. And the two that I have that are pyroclastic up here are the pumice and then the scoria. And the only reason why they look, and this one's more dense, you can feel it, but this has more of an iron content and this does not. This is more of a silicate content. Examples of this, As I said, pumice and scoria. Top is like that very, very, very fine volcanic ash. If you breathe it, it will tear your lungs apart.
That's odd.
No.
I love you, girl with no lungs.
That's gross.
That's what push down and
I wouldn't recommend breathing volcanic ash.
What was those?
What would happen if you like drink the lava?
If you drink
I
lava,
wouldn't
I'm pretty
drink
sure
straight
that it would like sear anything it touches completely and totally shut.
Yeah.
But like, so, wait, say that again?
Like, if you come in contact with lava, it's going to sear you, it's going to cook you, I would not try to drink lava. I would advise to not attempt.
So you're saying if I put my
Lava.
chicken in there, it'll think
I think it's like
It sounds
disappear.
funny to kill yourself with lava. Oh my
Well, I mean,
God.
if you jump in it, technically you'd already be dead. It's like if you jump, like, if you dove in it.
Like Joe versus the volcano, the old, is it Tom Hanks? It's before y'all's time.
Yeah, I don't know.
You don't know that one? Okay, so pegmatitic, and pegmatite, huge crystals. Okay, this is going to be your granitic magma, which we're going to talk about. Like I said, spend 3 days on igneous rocks. There are different types of magma. The slowest and most viscous of all of the magmas comes from where the granite forms, and it's extremely coarse grained. And I actually have a piece of pegmatite, or if you want to see it, you can. But they have these huge crystals, and I know they can't really see. They can't really see, but there's huge crystals. There's one right here. This particular sample of pegmatite has 2 very decent sized crystals within them. I've only seen, as far as pegmatite pictures, and then the ones that are in the samples that we have here in the classroom. And they can have all different kinds of what you think of as gemstones, minerals, giant crystals. Garnet would be one of them that can be supported in the rock structure. And so, fine grain, let's see if I can remember all of these and keep them all straight, because there's so many different phrases. This one's from inside the earth. It is intrusive. Intrusive tends to cool off slower, which tends to be more rough grained, which is pheneritic. The closer it comes towards the surface, in fact, if it actually comes out of the lava, those are going to be more extrusive. It actually exits the earth, which is going to normally have a much finer grain. Does not mean it has to have small holes in it, but it can. That's aphanitic. You have the morphic type, the metamorphic combination of the two, which is porphyritic. I have to keep all these straight. You've got ones that have all the air holes in it, which are pyroclastic, and then you have this type, if it's a pegmatite, it has these huge crystals in it, that's pegmatitic. Lots of different words that you are not used to. Sorry, I don't make most of it's going to be Latin. I don't make Latin. I'm not the one that named these things, people that discovered the different types of rocks. I had somebody ask me, are there types of rocks in the earth that we don't know about yet? Probably. I mean, it has to be at least a couple. I would think that it would be more like otherworldly, that we would come across something that is different with a chemical composition, like maybe asteroids or other moons. I'm not a geologist. There are other types of rocks besides these. Back here, let me pause this. I need to check. Hold on. I need to check